then start sharp at 5:05. Robotics and other combinations will make the world very fantastic compared with today, says Bill Gates. A very pleasant evening, one and all present here. A warm welcome to Optimus, a voyage to RoboLab. Great excitement and happiness for IEEE FISAT SB because it's our first virtual IV being hosted in collaboration with Inca Robotics, India's leading tech company specialized in robotics. It's an honor and privilege for me to welcome you on behalf of IEEE FISAT Robotics and Automation Society SBC. Now, let me invite Ms. Anushree Prakash CP to propose the opening address.
A very warm good evening, one and all. It's an honor to be gathered here with this group of wonderful people. I, Anushree Prakash, welcome you all on behalf of our whole family of IEEE FISAT RAS SBC to this event, Optimus, a voyage to RoboLab, which is conducted in collaboration with Inca Robotics. I am extremely delighted to welcome the Inca Robotics team, a group of innovative technocrats, R&D fanatic, strategic partners, and associates with a shared vision to create a strong, vibrant robotics and emerging technology ecosystem marks the framework of tech startup Inca Robotics, one of the most significant companies in India. Welcome, team. It's my pleasure to welcome our host, Ms. Praveena Nair. Ms. Praveena Nair, currently pursuing her career as the Senior Instructional Designer, Inca Robotics Solutions Private Limited. She is a trainer with a great passion for business English and verbal abilities training. She has been training corporate professionals and students across verticals on language skill enhancement for over 7 years, and she also has 19 years of counseling and client engagement experience. She's an expert in redesigning and developing courses or curriculums and creating training materials. I welcome you, ma'am. I would like to welcome all the coordinators and volunteers, as well as a very warm welcome to all the participants present here. Thank you.
Thank you, Ms. Anushree. Now it's the most awaited part of the day. I welcome our host, Ms. Praveena Nair, to begin our virtual IV. On to you, ma'am.
Everybody will come down.
Hello and a very warm welcome to all you IEEE champs.
You are here at a sprawling lab at 𝗜ʰ𝗏𝗏, which is a 4,500 square feet awarded lab here at 𝗜ʰ𝗏𝗏, and we are going to take you through an incredible journey of 3 different robots that we have here for you today. So friends, are we ready to go? Yes? Let's take you through 3 different robotic journeys today. The first one being the 𝗜ʰ𝗏𝗏𝗏, which is a beautiful industrial arm that we have here at 𝗜ʰ𝗏𝗏. And to explain you the features of this first type of drone, we have a very young roboticist called Ashwin with us. Ashwin is a product from St. Thomas College. Hi, Ashwin. How are you?
Fine.
Ashwin, we have a very, very amazing batch.
Attendees, sorry for the inconvenience, technical issues. So we can wait for 5 minutes.
So hi, all you IEEE champs. So welcome back. Now, let me introduce you to a very, very young, dynamic roboticist who is going to introduce you to the first set of robots here at 𝗜ʰ𝗏𝗏. And this is 𝗜ʰ𝗏𝗏𝗏𝗏 that we have here. Hi, Ashwin.
Hi.
So how are you?
Fine.
So Ashwin, how long has it been that you've been with 𝗜ʰ𝗏𝗏𝗏? I'm sure all these people would want to know a little more about the roboticists associated with us, right? So would you like to share the details with them?
Yes. Hi guys. I'm Ashwin. I've been here 3 years here, and I'm a senior robotics engineer here. And here I'm introducing a small robotic arm, which is a 𝗜HP magician. It's an educational purpose robotic arm. We can here you can see a small robotic arm. This is a 3-axis, 3 DOF robotic arm.
Okay.
So
So it will move in 3 different
yeah, it's moving 3
Right.
different directions. Yes, exactly.
Actually, നല്ലൊരു കിടു ആമാണല്ലോ.
Yes, yes, അതെ.
ഇതിന്റെ ഫീച്ചേഴ്സ് കുറച്ചും കൂടെ നമുക്ക് ഡീറ്റെയിൽ ആയി പറയാം.
Okay. ഓക്കെ, സോ ഇതെന്ന് പറയുന്നത് നമ്മുടെ ഒരു 3-axis, അതായത് 3 DOF റോബോട്ടാണ്. നമ്മുടെ എൻഡ് എഫക്ടറിൽ ഇതിന്റെ പെന്നാണ് വെച്ചിട്ടുള്ളത്. പെൻ വെച്ച് കഴിഞ്ഞാൽ നമുക്ക് എല്ലാവർക്കും അറിയാം, ഇത് എഴുതാം, നമുക്ക് ഡ്രോ ചെയ്യാം, നമുക്ക് വേണ്ട ഒരു രീതിയിലുള്ള ഒരു പടം അല്ലെങ്കിൽ ഒരു ഇമേജ് കൊടുക്കുകയാണെങ്കിൽ അല്ലെങ്കിൽ ടെക്സ്റ്റ് കൊടുക്കുകയാണെങ്കിൽ നമുക്ക് ക്ലിയർ ആയിട്ട് എഴുതിക്കാൻ പറ്റും ഇതിൻ്റെ അടുത്ത്. അതുപോലെ തന്നെ നമുക്ക് ഇതിന്റെ എൻഡ് എഫക്ടർ മാറ്റിയിട്ട് നമുക്ക് ഈ ഒരു രീതിയിൽ വെക്കുകയാണെങ്കിൽ ഇത് ഗ്രിപ്പറാണ്. ഗ്രിപ്പർ വെച്ച് കഴിഞ്ഞാൽ നമുക്ക് പിക്ക് ആൻഡ് പ്ലേസ് ആപ്ലിക്കേഷൻസ് യൂസ് ചെയ്യാൻ പറ്റും. ഇതാണ് ഈ ഒരു ആപ്ലിക്കേഷൻ. ഇതിന്റെ എൻഡ് എഫക്ടറിൽ നമുക്ക് കാണുന്നത് ഒരു പെന്നാണെന്നുണ്ടെങ്കിൽ ഇവിടെ നമുക്ക് കാണാൻ സാധിക്കുന്നത് ഒരു സെർവോ ആണ്. അപ്പൊ ഇത് 3 DOF ആണ്, പക്ഷെ ഇതിന്റെ കേസ് ആണെങ്കിൽ ഇതൊരു 4 DOF ആണ്. അപ്പൊ ഇതിന് നമുക്ക് എൻഡ് എഫക്ടർ വെച്ച് കഴിഞ്ഞാൽ ഇതിനെ നമുക്ക് റൊട്ടേറ്റ് ചെയ്യിക്കാൻ പറ്റും. പിന്നെ പിക്ക് ആൻഡ് പ്ലേസ് ആപ്ലിക്കേഷനുകൾ നമുക്ക് യൂസ് ചെയ്യാൻ പറ്റും ഈ രീതിയിൽ. ഓക്കെ, അപ്പൊ നമുക്കൊരു ഡ്രോയിങ് പോയാലോ? അപ്പോ നമുക്ക് ഇതിനെ കൺട്രോൾ ചെയ്യാനായിട്ടൊരു സോഫ്റ്റ്വെയർ ഉണ്ട്. ഡിബോർഡ് സ്റ്റുഡിയോ എന്നാണ് ആ സോഫ്റ്റ്വെയറിന്റെ പേര്. ഇത് നമുക്ക് ടെക്സ്റ്റ്, നമുക്ക് ഏത് രീതിയിലുള്ള ടെക്സ്റ്റ് നമുക്ക് എൻ്റർ ചെയ്ത് കൊടുക്കാൻ പറ്റും. അപ്പൊ ഞാനിപ്പോ ഇവിടെ നിലവിൽ ഞാൻ ചെയ്തിട്ടുള്ളത് IEEE എന്ന് പറഞ്ഞിട്ടുള്ള ഒരു ടെക്സ്റ്റ് ആണ് കൊടുത്തിട്ടുള്ളത്. ഞാൻ ഇതിനെ സ്റ്റാർട്ട് ചെയ്യുകയാണെങ്കിൽ നിങ്ങൾക്ക് കാണാൻ പറ്റും. ഇവിടെ ഞാൻ സ്റ്റാർട്ട് ചെയ്യാണ്. നിങ്ങൾക്ക് ഇവിടെ റൈറ്റ് ചെയ്യുന്നത് കാണാം.
അശ്വിൻ, എനിക്ക് തോന്നുന്നു ഒരു പക്ഷെ നമ്മൾ എഴുതുന്നതിനെക്കാട്ടും നല്ല ഒരു പ്രൊസഷൻ ഉണ്ട്. അപ്പൊ അശ്വിൻ, ഒരു ചോദ്യം എന്നെ മനസ്സിൽ പറഞ്ഞത്, എന്തെങ്കിലും ഒരു കോഡിങ്ങോ പ്രോഗ്രാമിങ്ങോ നമ്മൾ ചെയ്തിരിക്കണം ഇതിങ്ങനെ എഴുതാൻ പറ്റണേ. അപ്പൊ ഇത് ഏത് പ്രോഗ്രാമിങ്ങോ കോഡിങ്ങോ ആണ്
ഇപ്പൊ നമ്മള് ഇത് നമ്മുടെ ഈ റോബോട്ടിക് ആണ് എഡ്യൂക്കേഷൻ പർപ്പസ് ആയതുകൊണ്ട് തന്നെ 20 ടൈപ്സ് ഓഫ് പ്രോഗ്രാമിംഗ് ലാംഗ്വേജ് സപ്പോർട്ട് ചെയ്യും. including Python, ROS and C++, embedded C, Scratch, basic 5 ലാംഗ്വേജ്. അത് കൂടാണ്ട് 20 കൂടി സപ്പോർട്ട് ചെയ്യും. 20 ലാംഗ്വേജ് കൂടി സപ്പോർട്ട് ചെയ്യും. യെസ്. അപ്പോ ഇപ്പൊ നമ്മളിവിടെ കൊടുത്തിട്ടുള്ളത് ഇതിൽ പ്രോഗ്രാമിംഗ് ഒന്നുമില്ല. നമുക്ക് ജസ്റ്റ് UI ഉണ്ട്. UIയിൽ യൂസർ ഇന്റർഫേസിനകത്ത് നമുക്ക് എഴുതേണ്ട ടെക്സ്റ്റ് എന്താണെന്ന് അല്ലെങ്കിൽ ഒരു ഇമേജ് എന്താണെന്ന് വെച്ചാൽ അപ്ലോഡ് ചെയ്ത് കൊടുത്തു കഴിഞ്ഞാൽ ആ ഇമേജിനെ അത് G കോഡായിട്ട് കൺവേർട്ട് ചെയ്തിട്ട് അത് അവിടെ റൈറ്റ് ചെയ്ത് ഇപ്പൊ കാണാൻ പറ്റും IEEE എന്നുള്ളൊരു ഫോണ്ടിന്റെ സൈസും എല്ലാം നമുക്ക് അഡ്ജസ്റ്റ് ചെയ്ത് കൺട്രോൾ ചെയ്യാനും പറ്റും. യെസ്. പിന്നെ ഇതിൽ യൂസ് ചെയ്യുന്ന മോട്ടോഴ്സ് എന്ന് പറയുന്നത് സെർവോ മോട്ടോഴ്സ് ആണ്. സോറി, ഇത് സ്റ്റെപ്പർ മോട്ടോഴ്സ് ആണ്. ഇതിന്റെ എൻഡ് എഫക്ടറിൽ ഇതിന്റെ കേസിൽ വരണമെങ്കിൽ സെർവോ മോട്ടോഴ്സ് യൂസ് ചെയ്യാം. യെസ്.
കുറച്ചുകൂടെ കൂടുതൽ പ്രിസിഷൻ ആയിരിക്കും.
അതെ, സ്റ്റെപ്പർ മോട്ടോഴ്സ് വെക്കാന്ന് പറഞ്ഞാൽ കൂടുതൽ സ്റ്റെപ്പ് വൈസ് മൂവ്മെന്റ് ആയിരിക്കും. അപ്പൊ കുറച്ചും കൂടി പ്രിസൈസ് ആയുള്ള മൂവ്മെന്റുകൾ നമുക്ക് അവൈലബിൾ ആയിരിക്കും. യെസ്. പിന്നെ ചെറിയ സൈസേ വരുള്ളൂ. ചെറിയ കൺട്രോളിംഗ് ഹാൻഡിൽ ചെയ്യണം.
അത് പറയുമ്പോഴാണ് അശ്വിൻ ഒരു ചോദ്യം എന്റെ മനസ്സിൽ വരുന്നത്, ഹൗ മച്ച് വെയിറ്റ് ഡു യു തിങ്ക് ദിസ് പർട്ടിക്കുലർ ഒരു പർട്ടിക്കുലർ കപ്പാസിറ്റി ഉണ്ടാവും?
ഇത് ഒരു ഹാഫ് kg എഡ്യൂക്കേഷൻ ആരെങ്കിലും എടുക്കുന്നുണ്ട്. അതായത് എഡ്യൂക്കേഷൻ പർപ്പസ് ഉള്ള രീതിയിൽ അത്രേ വരുള്ളൂ. നമുക്ക് ഇൻഡസ്ട്രിയലായിട്ട് നമുക്ക് യൂസ് ചെയ്യാൻ പറ്റില്ല. പക്ഷേ ഇൻഡസ്ട്രിയിലുള്ളതിന്റെ ഒരു ലിമിറ്റ് ആണ്. എങ്ങനെയാണ് ഇൻഡസ്ട്രിയിലാകുമ്പോൾ വർക്ക് ചെയ്യുന്നത്, ആ രീതിയിലുള്ള എഡ്യൂക്കേഷനിൽ നമുക്കെല്ലാം മനസ്സിലാക്കാൻ പറ്റുന്ന ഒരാളാണ്.
അപ്പൊ അതിന്റെ ഒരു ചെറിയ ഓറിയന്റേഷൻ ആണ് ഇൻഡസ്ട്രീസിൽ നമ്മൾ യൂസ് ചെയ്യുന്ന ആംസ് എങ്ങനെയായിരിക്കും. ഇപ്പോൾ നമ്മുടെ നിലവിൽ ഈവൻ cars are being put together by heavy industries.
Yes.
Right? So this is just a basic version of a huge industrial arm. This is your first place to begin your journey towards industrial arms, as we say, right?
Yes.
I think this was very, very interesting. And എനിക്കിപ്പോ മനസ്സിലായത് ഇതിന്റെ എൻഡ് എഫക്ടർ മാറ്റി കഴിഞ്ഞ് നമുക്ക് ഏത്
നമ്മളിപ്പോ റൈറ്റിംഗ് പർപ്പസ് ആയതുകൊണ്ട് we are using a pen as an end effector. ഇതിനാണ് end effector എന്ന് പറയാം. Then if you change this with this one, this is a gripper. It works on the basis of suction.
Got it.
Okay. So ഇത് pick and place applicationകൾക്ക് യൂസ് ചെയ്യാനായിട്ട് സാധിക്കും.
All right, Ashwin, that was really, really incredible. And I am so thankful that you've taken us on the journey so very beautifully. Thank you so much, Ashwin. And guys, I'm sure you are excited to look at the next beautiful product that we have for you, right? Let me take you through a surprise. We at Inker have created our very own homegrown humanoid robot that you will see is as tall as I am, and this is Oᴘᴛ, my friends. Here is Oᴘᴛ. Can you see how tall Oᴘᴛ is? Almost my height. Yes, 5 feet, almost 2 inches tall. And Oᴘᴛ is a homegrown product. It has been created right here by our very passionate roboticists here at Inker. And I'm very proud to introduce one of the key people who was a part of this project called Oᴘᴛ. And hi, Arjun.
Hello.
Hi, how are you, Arjun? Okay, by the way, friends, Arjun is a FISAT product. And Arjun, would you like to tell us how your journey began at Inker? How long has it been? I'm sure they will all be excited to know.
Yes. I've been working for the last 2 years. Working here as a hardware engineer. Had to really work on this.
This incredible homegrown product of ours. Okay, great. Thank you.
Now, why don't we meet up?
Yeah, sure. Okay.
He's sleeping now.
Okay.
Why don't we wake him up?
Okay, he's in a sleep mode and also needs to be woken up. And how do I do that?
Push the button.
This one, there's nothing here. Okay. I also wake up. Yeah. Wow. Oᴘᴛ is all set. Right? Warming up. Yeah. Okay. All right. But in fact, we are also excited, Arjun. I want you to tell us everything you can about Oᴘᴛ, starting from the basics. Yeah. And let them know all that they need to know about this incredible humanoid robot.
First of all, now, this There's an education purpose for them built in-house.
Okay.
Actually, this can be used on, can be used for commercial purpose as well. But
Okay.
the first version we have made it for a dedicated application as dedicated purpose. Okay. So that we can all the young engineers out there can stay from this.
Wow. So Arjun, we created Oᴘᴛ so that students could learn robotics through a robot itself. Wow. It can't get better than that, right? Okay, Arjun.
So does that explain the hardware part? You can see some of the yes.
Yes, it does. It has arms like us.
Yes.
Has a head like us. Yeah. Okay.
Yes, we can basically divide this into three parts: the head part, the torso part, and the base.
Okay.
I'll explain the features of the head. You can see a display here. So this is the GUI of Oᴘᴛ. This
Okay.
is where we interact with Oᴘᴛ.
Okay.
On the software part where we interact with Oᴘᴛ, and you can also see that it has got a camera there.
Here, the dot that we see there on the forehead.
Yes.
Okay.
And it has an integrated mic also with that.
Oh, interesting. Okay.
And we have used two-axis degree of freedom motors there, so that it resembles a neck movement like that of
Just that, like that of a human being. Okay, that's very impressive. What about all this white hardware part? How was all this created, Arjun?
Yeah.
This is what excites me, especially the arms, the speaker portion, everything here. Yes.
All those parts are 3D printed, ma'am.
And in-house at Anchor?
We have designed them and we have 3D printed them in-house. Every white part of it.
Beautiful. Must say this is a great robot that you got put together. And how long did it take for you to get this?
It's almost 3 months, ma'am. 8 months. So actually, this is actually this product for us. This version of Oᴘᴛ, we are using that to try out our new updates, try out our new features.
So if there are any new features to be embedded, you would use all
test
of
that
them
on
for
this.
all those purposes.
Yes.
That's interesting.
Yes.
Okay.
Okay. Then we'll talk about the next part, ma'am.
Yes.
You can see 2 arms there, right?
Yes.
Actually, these are
This is our arms.
yeah.
Okay.
So to resemble our arms, we have used 6 motors so that
Okay.
we'll get 6 degrees of freedom,
All right.
and we have used servo motors for that.
Right.
So it gives an human arm like simulation.
All these are servo motors.
Yeah, we
embedded?
have actually got 6 of them. One
6
is
of them.
right
This is
here.
the first one. Okay.
Second one, third one,
Third.
fourth one is here, fifth one is here, and at the last one we have an end effector.
Okay. Just as we have the wrists and fingers.
Yes,
Something
yes.
similar.
We have used a gripper as the end effector for this version,
Okay.
so that
It can hold things,
it
right?
actions can place.
So you have all those servo motors so that it can move its arm just like we human beings move our arms
Exactly.
with the help of muscles and bones, right?
Yes, yes. That's
So this is a lot of thought put together, I would say, Okay, another thing that comes from my entire why is it that all things so bad? I mean, I don't see any power.
Yeah,
It's so bad.
yeah, it's easily robots. Then it's very
No.
yeah. It's that it's inside.
So the main idea is you learn robotics, understand what goes inside a robot, just to be bare right, and it becomes easier to understand the whole concept. Right? So I think that again is a great thought put together there. Yeah. Beautiful. Okay.
Yeah, and so you can see so many different ports here.
Yes, I can see every connection. It's so transparent. Yeah.
Yes, ma'am.
Okay.
And this thing right here
Mm-hmm.
is the brain of the atom.
Okay.
This is actually a Raspberry Pi.
Raspberry Pi. Okay, so that's the mother controller.
That's the brain.
Yeah, that's the brain of Oᴘᴛ.
Yes, that
Raspberry
controls,
Pi.
all the modules of the atom.
Okay.
And we have another development board right here.
Mhm.
These are the Arduino boards.
Yeah, it says right, head, left. So each of these Arduino boards goes to each of those parts.
Yes, exactly.
Okay.
We have said that this is a modular robot.
Yeah.
So the reason we are 100% justified to that.
Yeah.
And every part of it, like the head part, both the arms, those can be taken out and work separately.
Oh, interesting. So that
And
means
each of this, sorry to interrupt.
it's okay.
Each of these, Arduino boards
Yeah.
control those modules. This
That's
is for the
very
right
interesting.
arm, this is for the head,
Head.
and this is for the
This was the left arm because it says left, right?
Yeah.
And it has a small drawing also.
We have
Okay.
written it for our,
All right. Actually, it would be nice if we can see any of the features of Oᴘᴛ. I'm sure they're all very excited and they would like to see some act done by Oᴘᴛ. So we can just have anyone can display it to our crowd out here. Really? I don't mind. So guys, lucky me, I'm going to give Oᴘᴛ a shake hand or rather, give him a shake hand. Let's see how it goes. Okay. Yes, I am excited. All right.
Here it goes.
Okay, Oᴘᴛ, I'm ready. Are you? Oh, wow. Did you see that? That was really, really incredible. I'm excited. Okay. We just embedded and program. Python.
C language.
So all that put together, Oᴘᴛ can do a lot of things for us, right? A lot of things for us. Okay, so we have some idea about the head portion and the torso. Or what about the base portion?
You can see there are so many complex wires there.
Yes, lots of them, yes.
Yeah,
as I can
we
see.
have actually connected 4 different wheels for our, 4 wheels for our.
These wheels look very different from the usual wheels, Arjun. Is there anything unique about these wheels?
Yes, ma'am, we have used only wheels.
Only wheels, only.
Yes,
So it can move anywhere, you know?
yes,
Yeah?
exactly.
Okay, all right.
I'll show you some moments of it.
That would be very interesting. I'm sure our audience is all excited to see how Oᴘᴛ would play. Interesting. Oh my God.
See, yeah,
Everything that has gone into Oᴘᴛ can be seen, right? By seeing it, so it comes back. You see that, friends? Yeah.
you can see that.
Yes.
That's where we have used.
All right. Yes. And another very important question that comes to mind, Arjun, like any robot or like any electronic, product. I mean, there is a power source. Even we have our power source, which is energy that comes from food. So what about Oᴘᴛ?
So of course, there is a battery.
Okay.
You can see the battery there. This is
Okay, this blue box that I see here, this one?
Yes,
This
yes.
is battery for Oᴘᴛ.
This is the battery bottom.
Okay.
This is like lithium-ion battery I used.
Oh.
So that it stand up more.
All right. And how long can Oᴘᴛ be operational, on one battery charge? Roughly.
The working time also can be 4 to 3 hours.
Okay, not bad.
And my standby time will be much more.
Much more. Yes. Right. That's really impressive. Arjun, thank you so much for taking us to teach us this results as concerned. I am sure all you technocrats of the future will have a lot of questions with regards to Oᴘᴛ. Do feel free to ask us. If you want to ask us now, we are okay with it. If not, if you want to hold on till the end, till I introduce you to our third really incredible robo, the flying robo, the drone, we can have all our questions put together towards the end of this session, right? So guys, I am now going to take you to yet another amazement that we have at Anchor, and this is our Anchor drones. We call it Prithvi 1 and Prithvi 2, and we have a very, very dynamic IIT product, Mr. Karthik with us, who will explain us all the time. Hi Karthik, how are you? It's always very exciting to see that smile, Yeah. So Karthik, I was just telling our champions out there that so you are going to tell us about this incredible drone that you see the dimension, guys, how big it is, And these are real operational drones.
Yeah.
Yes, but I don't want to talk much. Karthik will take us through this entire journey. So Karthik,
Yeah.
the stage is all yours.
Yeah.
Okay.
So, let me begin by just saying, I'll introduce myself. I'm Karthik. I did my BTech and MTech from IIT Madras in robotics, bachelor's in mechanical engineering. And I've been working here for about 9 months, so it's roughly about a year now. So let's just come back to our product.
I'm sure it's a very exciting journey, right, Karthik?
Yes, it has been really exciting.
All right. So Karthik, over to you.
Yeah, so we have our 𝗜HP series of drones.
Okay.
This is our first version, and I'll come to that later.
Okay.
Yeah, so as far as robotics goes, in a 3D space, there is only two methods to carry objects. One is an arm. We just saw that arm. So if you have a big enough arm, you can move it. The next best method is flight, and that is drone is what we use for moving objects from one place to another in a 3D space. So that is why we have the need of a drone. This is 𝗜HP-1. We've engineered it to industrial standards. It's, as you can see, it's pretty huge. It has a wingspan of about 6 feet. And these propellers, they themselves are about 0.8 meters, so it's roughly about a meter long propeller.
Can you give an idea of the dimension? This is how big the drone is. All right.
Yes. So why the big drone and why the big propellers? Because it has a very good payload lifting capacity. That's about, it can take about 15 kilograms of weight. So where do we use it? Agri-tech is where we use. So we use these robots, these drones for agricultural purposes. So one of them is we can, if you have acres of land, you can have the seeds distributed evenly, way better than manually with way much more efficiency. Also, for if you have to go up a tree and then spray some pesticides or something, it takes another loss of efficiency because one has to get down and climb another tree. So all these problems are together sorted in one move, and that is why we have 𝗜HP. So I'll just let you know about few of the technical specs. So as I said, it's 6 feet. Propellers are about a meter long. It can carry about 16 liters of pesticide or whatever fluid. Yes, this is the tank where we
This is where we fill up
fill our
manure or fertilizer, whatever it is.
and we have 4 nozzles.
Yeah. SBC. These are the nozzles which are used to spray the pesticides onto the fields.
Yeah, we have 4 nozzles here on 6 of these propellers. Except the front 2, we have 4 on all the other wings.
Yes.
So yes, so as I said, we can have a maximum payload in terms of liquid to be about 16 liters.
Very good. That's quite a lot.
Yeah, and ma'am, so we figured it out that we can cover an area of about 1 acres in 20 minutes.
That's not bad at all. But
That's actually excellent. You can cover in 20 minutes. You can
that's
have,
a huge acreage.
yeah, you can have an entire field sprayed or
And evenly like this.
and
right?
evenly, yeah.
Karthik, I think this is a big boon or blessing to our agripreneurs for the simple fact that we are at a stage where it's difficult to find manpower to work on the fields, right?
Exactly.
And 𝗜HP-1 could be an answer to so many questions.
In terms of availability of labor and also the cost of labor. So if this is a one-time investment and you can have much more productivity over a period of time, and it's definitely a must.
There are 2 questions which come to my mind, Karthik. You know, everything has a power source, is my favorite question. And so what is the power source for our 𝗜HP-1? What is it?
It does sound like a generator is there inside, but now it runs on electric power.
Okay.
So we have lithium polymer cells. I have them removed for your
For an easy witness.
Yes.
Right?
Yeah.
Okay.
So this is a 6-cell lithium polymer battery, and it has a charge capacity of 22,000 milliampere hours.
Okay.
So both of these will take about an hour or an hour 15 minutes for a full charge, and you
Okay.
get 20 minutes of runtime with it.
Okay. And how does this get controlled, Karthik? I mean, how does it get controlled? Who controls it?
Yes.
How is
So-
it done?
Yes. So we have this is our operating controller, if you could.
Okay, this is a controller we have for our drone here. Okay.
So this runs on RF frequency, radio frequency. So it transmits whatever signals we need onto the robot.
Okay.
The robot has another controller. It's called 𝗜HP.
Okay.
That 𝗜HP, we transmit information from here to there. It receives that information. Along with it, it has an autopilot mode.
Okay.
So there are gyroscopes and accelerometers on board that let you know in what angle the drone currently is,
All right.
and whichever side the angle is low, on the opposite side the drone will rotate faster so as to stabilize it, and it runs in real time, so it balances itself in real time. So even if it hits a bird or something mid-flight, it will manage itself and not make sure that it doesn't fall off. So we've seen small drones are mostly they're called quadrupters.
Right.
Quadrupters have a problem. Yeah, they are energy efficient. However, if one of the wings fail, it's definitely going to fall.
Collapse, right? Yeah.
A drone of this size, you cannot afford for it to fall down and hit somebody or something.
Yeah.
So the 6 wings, even if one of them fails, the other
The
5
other
will
five
manage.
balance. Okay, and that's exactly what is required of technology, right?
Yes.
Okay, that's interesting. But I see another beautiful bank opposite here.
Yes.
And what is the difference between these two? If you could just take us through some of the features there. Guys, as you can see, this is a beautiful, bigger drone, I would say, as compared to 𝗜HP-1 that you saw. And Karthik, I believe that's 𝗜HP-2 for all of us, right? Okay, so could you just take us?
Sure. This is 𝗜HP-1, and we needed more updates and a better drone, and hence we have 𝗜HP-2. So
Look at this, guys. Yeah, can you just map the dimension? I'm just standing here with my arms spread out so you get an idea of how big this whole thing is. All right, Karthik.
yeah, so with respect to size and its payload capacity and its power source and its controller, it's pretty much the same.
Okay.
We've introduced improvements.
Okay.
One is this granular spreader that you can see here.
All right. Yeah, this is missing from 𝗜HP-1, right? Okay. Okay.
So what does a granular spreader do? That the 𝗜HP, yes, exactly.
Okay.
So 𝗜HP-1 could only spray liquids.
Yes.
𝗜HP-2 can spray liquids, also spread grains.
Okay, so
And
if we need to, sprawl or put grains or seeds into the field, this is the right
Yes.
option for us,
Exactly.
right?
Yeah. So we'll have our seeds inside through this container,
Okay.
and it will fall down here, and this spins at a very high RPM,
Okay.
which spreads the grains evenly.
Very interesting.
That is one improvement. The other one is you could see is this on
Nozzle, right?
yes, on two of our wings we have. These are not special. These are special nozzles, not
Not
similar.
the similar ones.
Yeah,
Yeah.
those ones spray droplets.
Yeah.
It's just like a normal spray.
Yeah.
However, this is called an ionized sprayer.
Okay.
So what it does is the liquid that we need to spray,
Yeah.
it is first charged.
Okay.
So it acquires a negative charge,
Okay.
and then because it's negatively charged, it goes away and spreads around.
Okay.
So it will have a smaller droplet size.
Attendees, sorry for the inconvenience. Some technical error, so please bear with us.
And just due to the technical issues, we lost connection for a few seconds. We are back.
So welcome back, guys. Sorry, that was the flip side, the tiny flip side of technology. We had a small technical snack, and here we are back again. So Karthik, we just a couple of more things to clarity on. One, talk about the range and the height to which this cannot be.
Okay.
Very important question, right, guys?
Okay. So since, as I said, it can cover an area of 1 acre in 20 minutes. So clearly we need a big range.
Yes.
So we tested and made sure that we can run it within a radius of 2 kilometers. So you are standing in the middle of the field.
Yeah.
You can have you can operate it anywhere around 2 kilometers. And it goes up to a height of about 15 meters. We've set it that way because if at all mishappening happens,
Yes.
primarily a person or the thing that it should be saved, and secondly our own also should survive. So we set it at a safe height.
Oh, this is very, very impressive. Yeah? So, guys, we took you through a journey where you have witnessed three incredible robots. The first one being 𝗜ʰ𝗸𝗶𝗿 𝗥𝐺𝗯𝐿, the industrial arm. The second was our very own homegrown humanoid robot called Oᴘᴛ. And the third was, of course, something we're all very proud of, 𝗜ʰ𝗸𝗏𝗏 1 and 2. Right? I'm sure after witnessing all this, I'm sure there are a lot of questions that you have on mind. And let us just have all our technical team together. And any questions that you have on mind, please put it across. And we have my team here, Ashwin, Karthik, and Arjun, please join us. And I'm sure our technocrats of the future have a lot of questions on mind, which they can put across, and we are all here to help you with your queries, right? Okay, guys. So I hope you enjoyed this session. There was some interesting learning element involved. And let us know if there's anything on your mind right now, and we are here to support you. Okay, here we go. Yeah, any questions, friends, please put it across, and we are here to support, absolutely. Any questions on the bot magician, on Oᴘᴛ? I'm sure you would have a lot of questions about Oᴘᴛ. And of course, 𝗜ʰ𝗸𝗏𝗏 1 and 2 are incredible drones, right? Agri drones, I would say. So any questions that you have, please put it across, and we are all ears. Okay. Any questions, Ashwin, our champions have as yet? You don't have to be shy. ധൈര്യമായിട്ട് ചോദിക്കാം. എന്ത് question മനസ്സിലുണ്ടെങ്കിലും ചോദിക്കാൻ നമ്മുടെ ടീം ഇവിടെ തന്നെ ഉണ്ട്. നിങ്ങൾ രണ്ടിന് താഴെ തന്നെ വിറ്റ്നസ് ചെയ്തുണ്ടാവും അല്ലേ? So any questions that you have based on these, please let us know. I'm sure their mind must be blazing with a lot of questions, right? Okay. Okay, they're all getting geared up to question. Chai, we would love to hear from you. I hope you enjoyed this session. There was a lot you could take back home, and I'm sure your mind must be thinking about a lot of things that you just witnessed, right? And by the way, guys, I invite all of you to come over and visit 𝗜ʰ𝗸𝗏 when the situation is right. And, we have more than 20 to 22 robots right here in this sprawling space that you see. And we would love to take you to every little robotic element that we. So, guys, let's hear from you. So I hope once the situation is okay, we get to see each of you walking into our 𝗜ʰ𝗸𝗏 office to witness every robot that we have here in housing in this sprawling 4,500 square feet space. All right.
We can also know play
Yeah, in fact, this is just the place, friends. If you are a very, very passionate roboticist, or if you are a very futuristic individual, technocrat of the future, this is just the place for you, because 𝗜ʰ𝗸𝗏 definitely supports and, it takes creativity to the next level. So if you who has a mind to create your own robot or your own technical innovative thing that you want to put into action, this is just the place, right, Arjun? Well, you are all witness to this, and Arjun, in fact, was a very critical part of the team that created Oᴘᴛ, right? Okay. So, guys, come on.
Hi, ma'am. Is it audible?
Ashwin,
Yes.
yeah, it's audible.
Hello.
Yeah, he introduced this working now. Aisha has a question.
Okay.
He projects. Yes.
Okay.
Yes, Aisha, we have lots of new projects and including some robotic projects like robotic arms and automated vehicles and some more curriculum projects also we are working on it. And we are putting other projects and yeah, and one more thing to add, this is dog Karthik is creating, and Karthik and his team is creating another like a sport, right? Dying sport is called like a dog. Yeah, it's a four leg dog. And yeah, I think Karthik will explain more about it.
Yes, sir.
So, it is a road naked walking robot which can dynamically balance itself. And the reason for designing it is wheels cannot cover all terrain. Wheels are built with legs, and when you limit nature, the best we can get to is naked robots. So naked robots can walk upstairs or get lifts or cover any terrain. So that is the inspiration towards building.
Excellent. And guys, because we at Inter believe it is very important to start early in life, we also have a digital program for school kids starting right from, I would say, grade 5 upwards, all the way up to 12th standard, where we give students an opportunity to create their own robot sitting right at home through a kit that gets delivered to them. And we train them through our incredible learning management system, and they can follow 50 plus videos for each of the projects that we have, and they can come out with their own robot. And some of the projects we have here would be a 𝗜ʰ𝗶𝗿, wherein a student can create his own humanoid robot that can dance, that can interact, and that can make 60 to 70 different kinds of sounds using a buzzer. The second project that we have through this project is something called Make Your Own First Robot, which is a great initiation into the world of robotics, where you can create your own first robotic car, which is an obstacle avoidance car that can be created. And the third most entertaining, the most engaging project that we have is for the higher standards. It's called Tinker with IoT, where we introduce students to the concept of Internet of Things. They would be able to create their own burglar alarm for the house. They would be able to create their own moisture sensing robot, and a whole lot of projects, using this one page. And of course, in the process, understand the nuances of this technology called IoT, right? And what you see in Karthik's this small cute little robot is our 𝗜ʰ𝗶𝗿, the robot, the humanoid robot that I told you can be created by students. And this can dance. You won't find a human being doing such beautiful moves, moving moves like a 𝗜ʰ𝗶𝗿, and it can even create 60 to 70 different sounds using a buzzer. So the entire nuance of robotics can be introduced to students, to school students, through these small, tiny digital learning projects that we have for every student. And this is a great way of introducing the students to the future and making them future ready, which is what Inker is all about. So guys, what have you got to say about, the other projects that we have, any upcoming projects you would like to talk about? We just spoke about sport, we just spoke about our digital learning programs. Any project which you feel is the right time to share details about, or to come up with it? Okay, yeah, sure.
We have another question. I guess there are any internship or courses that you that can help aspiring robotists who would want a hands-on experience.
Yes, Ashwin, another Ashwin asking Ashwin a question, right? Ashwin, yes, like I told you, Inker is all about promoting creativity. We are a very futuristic organization, and if any of you wants to be a part of the future, if you want to do your internships, if you want to do courses with us, yes, Inker has some incredible opportunities for you. If you just leave your contact details with us, we will ensure that our customer services team will come back to you with all the details that you would need to know further about the courses that we offer. And trust me, this would be your great initiation into the world that is futuristic and ahead of us. So yes, we welcome you with open arms. Please contact us and come back to us on whatever queries you might have on the courses that we have, right? And we can share our number in the chat box so that they can always come back to us. All right, that is a great question. Thank you for asking that question. I appreciate it.
Any other questions?
Any other questions? Champions, please go ahead. Yes? We wait for
Yeah, Roshni Jones is asking how to get started with robotics after BTech. I think
great person, great resource plan.
Roshni, can you specifically which field you are?
Is it mechanical? Is it civil?
Can you mention your BTech?
Maybe I can handle it.
She's doing yes.
Computer science. All right.
All right. So, in order to create a robot, we need three expertise or basic above average knowledge in three different fields.
Okay.
One is mechanical engineering.
Yes.
You need basic mechanical engineering to create the physical aspects of the robot. Secondly is electronics, that forms a nervous system of the robot. It conducts information and does communication between different parts. And then, of course, we need a brain. So the coding is done, will be done on a microprocessor and on the secondary coding. So since she is from a computer science background, she would be very knowledgeable with basic, at least C++ and Java coding, Python coding.
Yeah.
So where information with respect to that is enough. With respect to electronics, Arduino is a very good starting point.
Okay.
You can buy it for about $500, and it's very easy C++ coding. Mechanical aspect of it is also pretty easy. Wheels, motors, gears. Just assemble all of them up. And then best method is to visit YouTube, and they have people have like tons of ideas that can be done at home. So just anything that sparks your interest and creativity, just choose one and go for it.
Yes. So I hope that was beautifully answered and put by Karthik. Thank you, Karthik.
Ma'am, there is another question working on any COVID for health-related robots. Yeah, we created a robot. It's an automated curtain worker. It carries a UV. UV light to the functional disinfection, destroy the coronavirus in beds and rooms and water rooms, etc. This is a COVID project. Recently, we have done it. Yeah, this is the what project we created in COVID or health-related.
And in fact, we also had a special project for school students where we initiated them. We sent them kits, send out kits, with which they could create their own automated hand sanitizing kit machines, which was given out to students.
Yes.
That was also a very highly appreciated project that we did at the beginning of COVID, right? I think this was in 2020, May or June.
Yes.
So that we had that project, and I think that was a great success story.
Hands-free sanitizer.
Hands-free sanitizer.
There's another project, hands-free sanitizer. We are done as a project for school and college students. They can create their own sanitizer dispenser without any external buy. We are provided some kits and everything.
Very, very basic kit, and it was very easy to assemble through the review sessions that we offered them. And I think it was a great success with a lot of students. All right, any other questions? our champions out there have. Guys, thank you. Keep those questions coming. This is so interesting, and I can see there are a lot of think tanks sitting out there, in front of us. So, any other questions, please feel free to ask. Ashwin, anything else? No further questions? So guys, we would really appreciate if you would be in touch with us. We will share our number in the chat box. We will share our email ID. Please make sure that you get in touch with us. Should you have any queries or questions, even after the session, please feel free to contact us. And we are all eagerly waiting to hear from each of you out there.
There is one more question.
Yeah, okay. Yeah, sure.
By 𝗜HS
Yes.
he's asking why not using iPad in humanoids?
Biped humanoid. Well, Govind, this little friend of ours out here, this 𝗜ʰ𝗶𝗿 is a biped robot that we have created for the school students through our digital learning platform. Yes, we do use biped as well.
Yes.
There are all varieties you can talk of when it comes to biped robotics.
You can check the videos on YouTube.
Yes, we will find the beautiful videos of making videos of these projects on YouTube, on our channel. Anything else, Ashwin, to bring us?
Okay. Going is it clear?
Govind, I hope we've been able to answer your question. Yes.
Yeah, Karthik will add one more thing today.
So yeah, so our humanoid is at least very human-like from the waist above. Only that it has wheels. We don't have wheels. We have legs. So your question is that why don't you use legs? So you might know that it takes about 2 years even for a human to learn to walk. And wheels are the best method for transportation that takes the lowest amount of energy. So and it is the easiest to control also. So giving it omnidirectional wheels gives it the ability to move fast, turn around in any manner, and it doesn't fall by default. So you don't have to dynamically balance it. So as you know, walking on two legs is a pretty difficult task. They are on it also. That is how we started with the four-legged one, and very soon we're standing on two legs also.
Hope that answers your question, my friend. And our friend Oᴘᴛ here has only wheels, Probably our next version might have legs on which walk, but not legs. Okay, I hope that answers your question, Govind, Any other interesting questions that our champions out there have? The time is up, right? So, champions, thank you so much for spending that precious 1 hour of yours with us. We had a lot of fun with such an interactive audience out there, and I hope we get to see you again in the near future. And once, like I told you, once the situation is okay, please walk into the INCR office. We would love to have you guys here, and we will personally take you around every robot that we have here at INCR Robotics, right? And welcome to this awarded lab whenever you are ready to move around freely, right? So on that note, guys, I would say thank you so much from all our team members here, all of us at INCR, and God bless you. Stay home and stay safe. Yeah? Bye. Ciao.
Hope there is no more questions. We'll move on to with other sessions. If you guys have any more queries, please feel free to all contact them. And thank you, Team INCR Robotics. That was an amazing session. And thank you for your valuable time and contribution. It was a great pleasure to have you with us. We really appreciate your effort and your expertise. Thank you for the wholehearted cooperation. Looking forward for more virtual IVs in the future in collaboration with INCR Robotics. And I request all the attendees to switch on their cameras for a snap. I request everyone to switch their cameras on. Thank you, everyone. The feedback form link will be in the chat box soon, so kindly do fill the same. So now, let me invite Ms. Arshia Ashok to propose the vote of thanks. On to you, Arshia.
Be thankful for what you have, and you will end up having more. A very warm good evening to one and all present here. I deem it a great honor and privilege to propose the vote of thanks for the event Optimus conducted by IEEE RAS FISAT SBC. Let me first of all start by thanking Almighty for making today's occasion a valuable and successful one. I extend my bouquet of thanks to Inga Robotics who collaborated with us and found time to grace this occasion. This was a valuable contribution which gave an insight to know more about robotics and emerging technologies. As you all know, pandemic has lessened our opportunities, but today Inca Robotics made it possible by providing us a great chance for a virtual IV. It was such a pleasure for us to have Inca Robotics with us. As a token of love, we would like to present a virtual memento to the company. I thank everyone who made Optimus a great success, especially the coordinators and all who worked behind this wall project for making us aware of these technologies. And I'm pretty sure it was such a great experience for each of us. Last but not least, I thank all the participants for your sincere cooperation. I once again thank everyone for your valuable time. Don't forget to fill the feedback form attached in the chat box.
Thank you, Ms. Arshia. And that marks the end of our event. Thank you, each and everyone, for joining us today. Thank you.